now that we have seen some of the basic robotic sensors, and we have also gone through some general idea of electronic setup for a robot, let's use that knowledge to set up a simple AUV electronic setup. So let's start with defining the basic component that we need to develop the electronic setup for an AUV. Initially we need the sensors. Here I am taking IMU, camera and pressure sensor. Then we will go for the actuators, thruster and servo. Then we have our processor RPi and controller Arduino. Then our basic powertrain setup will have battery, buck converter and voltage splitter, and we will also add a failsafe setup RF as well as a relay setup, which we might use for miscellaneous activities like drop weight or light changing. So let's start designing with the component that we have. Let's take the battery. And assume that the battery is 4 cell, which is 16 volt. Then you have your sensors, camera, IMU and pressure sensor. Then you have your processor RPi and controller Arduino. Next you will go for the actuator, thruster and servos. Next we will be also including the failsafe mechanism RF, and for miscellaneous activities we will also use a relay, the electronic switch. Then we will these are the basic components. Now we will also include the powertrain components, which include buck converters. Here for our example, let's take our thruster will be working in 16 volt, servos will be working in 9 volt, RF and all other components will be working on 5 volt each. And here one more thing to notice is all the sensors will be powered directly from the processor itself, that is RPi. So we don't need to give separate powertrain to them. If there is any other sensors like sonar or other sensors, they might have a high power need, and there you might need to give separate power to the sensor from the powertrain. But here, since we are using basic sensors which are also 5 volts, you can take a power directly from the processor. So we should, since we can see here there is 2 voltages on the primary voltage, 9 volt as well as 5 volt. So as you can see here we have to have 2 buck converters, because we have 2 different voltage which is different from our primary voltage. It is 9 volt as well as 5 volt. So we have defined 2 buck converters. One will convert from 16 volt to 5 volt, and another will convert from 16 volt to 9 volt. So here one more thing to notice is here our thruster is 16 volt, which is the same voltage as our primary source. So there is no need to do a buck conversion, as so to say. So we can use a voltage separator, which will divide the voltage parallelly, one to our thruster directly and other 2 inputs to our buck converters. So these buck converters will take 16 volt and convert them directly to 9 volt. One 9 volt and one will convert them to 5 volt. And the 9 volt can be directly given to our servos, and 5 volt coming from the 5 volt buck converter can be connected to a voltage splitter and can be splitted to 5 volt needing components. One is like RF, relay, then we can connect them to Arduino as well as RPi. So here you can see our basic powertrain setup is done. Here we have given power to each of the component according to their needs. Now let's talk about the signal processing. So one sec, I will change the pen for that. So here let's start from the sensor. From the sensors we are passing the data to your processor, which will process using autonomy algorithms and decision making algorithms, and finally it will give out control inputs. That control inputs will be transferring from RPi to your Arduino, which will then pass it to your actuators. servos and thrusters. Then one more thing here to notice is the RF will be connected to your Arduino always in loop, so that if something goes wrong with your autonomy code, you can get back control to your robot using fail-safe mechanism. Then also you can connect your Arduino to your relay if you have some miscellaneous activities. For example, you have a cooling fan in your robot to cool, so this you can activate using your relay. So this is the basic powertrain as well as signal transferring, which comprises the entire electronic setup. So I hope you have got an insight to design your own electronic setup for an AUV. Now let's see a physical implementation of designing the electronic setup. And here in our lab we have developed and designed the electronic setup for an ASV, autonomous surface vessel. Here you can see in the picture to the left, it also mostly resembles with the design that we had done before. Here you have sensors like IMU, GPS, and also there are camera sensors which is not in this image. Then you have the processor here, which will be taking the values from the sensors. Then you have controller Arduino here, which will be taking input from the processor and it will be passing to the different actuators. Here you mainly have 4 actuators. It's an over-actuated ASV. Here each of the AC denotes different 4 thrusters. Then you can also see the powertrain setup, where you can see our different 3 buck converters, because in this design we had sensors who need 3 different kind of power ratings, which is different from our primary source. So here also one more thing you can see is this is our RF controller. So this will also be passing data to our controller to have a fail-safe mechanism in the loop. So I hope from this session you have gained enough intel to design your own electronic setup for a robot, even if it's a AUV, ASV or any robot. So this concludes this session. Next session will be taken by my colleague, which will be more in terms of what are the algorithms and what are the decision making algorithms that we are talking about, which will be going through the processor that we collect data from the sensors.